IPv6 over MPLS. In this video, again, I'm going to talk about one of the other methods for carrying IPv6 over an MPLS backbone. The name of this method is 6PE. 6PE is the abbreviation of the IPv6 provider edge, or 6PE. IPv6 is equivalent to the 6, and then provider edge is PE. IPv6 provider edge, okay? The IPv6 provider edge, or 6PE, is an IPv4 to IPv6 transition technology. This technology allows ISPs to provide access services for scattered IPv6 networks over existing IPv4 backbone networks. In this way, CEs on IPv6 islands can communicate with each other through IPv4 PEs. For example, R1, as you can see, is one of the PE routers. This PE router connected to the IPv4 network because service provider using only IPv4, and here it connected to the R6, and the R6 and R1 communicate with each other with the IPv6. Okay, this means that the R1 is one of the 6 PE routers. Let me write here. This is the 6 PE router. 6 PE router is a dual stack router. Okay, this is the first 6 PE, for example. Also, we have another 6 PE routers, and also the R2 is another, and finally the router 4 is the 6P routers. Okay, let me to configure the 6P router or 6P services. After that, we can compare it with the, for example, 6VP. But as the start of this scenario, let me to say that in 6PE method we don't configure VRF. Maybe it's interesting or surprising to you that we don't need to configure VRFs in the PE routers. Here, as you can see, we have two customers, customer A and customer B. We need to give the reachability service for to customer A, site 1 and site 2, and also customer B, site 1 and site 2. Okay, as you can see, the R1 connected to to customer A site 1, and R3 connected to customer A site 2, and R2 connected to customer B site 1, and R4 connected to customer B site 2. In this video, I'm going to show you how we can configure the 6PE method. Let me start the configuration of this scenario. The first thing that we need to configure is the ISP or service provider's internal networks. After that, we can talk about the 6PE configuration. This is the CLI of the router 1. In router 1 and also router 2, router 3, router 4, and router 5, we have similar configuration that we did in the previous scenario. Let me start with the configuration of router 1. In router 1, we can start the configuration of the, for example, R1 with the IP addressing interface fast Ethernet 00. The IP address of this interface is 10.151.255.255.255.0, and then no shutdown. Okay, and after that, we need one loopback interface loopback 0. The IP address is 192.168, for example, 254. You know that here we need one loopback interface 2541 quad 255, and after that, this is the loopback 0 configuration in R1. Let me to configure the router 2. This is the router 2 with same configuration interface fast Ethernet 00. The IP address is 10.252.255.255.255.0, and then no shutdown. After that, interface loopback 0. IP address 192.168.254.2 quad 255. Then we need to configure the router 3. This is the router 3's configuration, conft interface fast Ethernet 00. The IP address is 10.353.255.255.255.0, and then no shutdown. After that, interface loopback 0. IP address 192.168.254.3 quad 255. And after that, we can configure the router 4 conft interface fast Ethernet 00. The IP address is 10.454.255.255. Okay, 255.0, and then no shutdown. After that, interface loopback 0. IP address 192.168.254.4 quad 255. This is the configuration of the R1, R2, R3, and R4 about the IP addressing. In R5 also we can configure the interface fast Ethernet 00. The IP address is for example 10.155, the fast Ethernet 00, 255.255.255.0, no shutdown. Then interface fast Ethernet 01. The IP address is, for example, 10.255.255.255.255.0. Then no shutdown. Interface fast Ethernet 10. IP address 10.355.255.255.255.0. No shutdown. And after that, interface fast Ethernet 11. IP address is 10.455, for example, 255.255.255, then 0. And after that, for example, no shutdown. Because here I'm not going to configure the VPN v4 BGP between the R5 and R1 or R5 and R3 or R2 or R4, I do not configure the for example, the interface loopback on the router 5. Let me to configuring the OSPF in this scenario, starting with the first MPLS label range 100 to 199 in the R1. After that, we can configure the router OSPF 1 with the router ID 192.168.2541. And after that, we can configure, for example, the MPLS LDP auto config on the R1. And if you want, you can use network statement 10.151 quad 0 area 0. And if you want, you can configure the OSPF on the interface also. Network 192.168.2541 quad 0, again area 0. This is the configuration of OSPF and also MPLS on the R1. Let me configure the router 2. MPLS label range is between 200 to 199. Router OSPF 1, MPLS LD first, router ID 192.168.2542, MPLS for example LDP auto config. Then the network statement 10.252 quad 0 area 0, and after that the network 192.168.2542 quad 0, okay, area 0. Then we can configure the router 3. In router 3, we need first MPLS label range 300-399, router OSPF 1, MPLS LDP auto config. If it's better to first configuring router ID to 192.168.2543, and after that MPLS LDP auto config, and then network statement 10.353 quad 0 area 0, and finally network 192.168.2543 quad 0 area 0. And the router 4, this is the router 4 MPLS label range, okay, between the 400 and 499. Then router OSPF 1, router ID 192.168.2544. After that MPLS LDP auto config. Then network statement 10.454 quad 0 area 0, and after that network 192.168.2544 quad 0 area 0. And the last router is router 5. This is the router 5. First MPLS label range between 500 to 599. Then router OSPF 1, router ID 192.168.2545. Then the network statement 10.155 quad 0 area 0. After that network 10.255 again quad 0 area 0, and then network 10.355 quad 0 area 0, network 10.455 quad 0 area 0. Now we can check everything. MPLS LDP auto config enabled before. Let me check everything in the router 5. Show IP OSPF neighbor can show us that we have 4 neighbor. I didn't configure the IP OSPF network point to point. If you want, you can configure it. Let me to configure on the router 5 interface range fast Ethernet 00 to fast Ethernet 01 and fast Ethernet 10 to fast Ethernet 11. Okay. IP OSPF network point to point, and also in the router 1 interface fast Ethernet 00, IP OSPF network point to point. Router 2, interface fast Ethernet 00, IP OSPF network point to point. Router 3, interface fast Ethernet 00, IP OSPF network point to point. And then router 4, interface fast Ethernet 00, IP OSPF network point to point. That's it. Now in R5 we can check again, show IP OSPF neighbor. We have 4 neighbor with a state of full, and also show IP show